Sometimes we have to add or subtract rational expressions where the denominators contain opposite factors. And here's an example of this. We're asked here to subtract x minus 6 over x minus 4 minus x minus 2 over 4 minus x. So as you know, we need a common denominator always to add or subtract rational expressions. We do not have a common denominator at the moment. These two denominators are different. But looking closely at the two denominators, x minus 4 and 4 minus x are opposites of one another. They differ by a factor of -1. So in order to obtain the common denominator here, the standard procedure is to multiply one of the fractions, it doesn't matter which one, in the numerator and denominator by a -1. I'm going to choose the second fraction here. So I'm multiplying the numerator and denominator of the second fraction by -1. This will cause the two denominators to now be equivalent. Okay, and I'm grouping the two binomials there in parentheses. So multiplying the top and bottom, the numerator and denominator of the second fraction there by -1, we're going to keep the first fraction the same, x minus 6 over x minus 4, and then minus. Our second fraction, the -1, needs to be distributed or multiplied by the x and by the -2 there. So it's going to be a negative x, and a -1 times a -2 makes a positive 2. So the numerator of the second fraction is negative x plus 2. And in the denominator of the second fraction, the -1 also needs to be distributed and multiplied by the 4 and the negative x. So 4 times -1 makes -4. And negative x times -1 makes positive x. The denominator is -4 plus x. This is, of course, equivalent to writing it with the two terms in reverse order as x minus 4, which is what I'm going to do on the next step. So now we've got x minus 6 all over x minus 4 minus negative x plus 2 over x minus 4. I just switched the order of the two terms from the second denominator, which is it's a legal maneuver by the commutative property of addition. You can always switch the order of two terms that are being added. So the second denominator is equivalent to x minus 4. The two denominators are now identical. So we have a common denominator underneath each fraction, and they can be combined into a single fraction now by subtracting the first numerator minus the second numerator. So we've got x minus 6 minus the second numerator, negative x plus 2. Notice I'm putting the second numerator in parentheses. The purpose for that is to remind me to distribute the negative on the next step to clear the parentheses. All over the common denominator of x minus 4. This then becomes, let's see, x minus 6, I'm going to distribute that minus sign or that negative symbol there. So negative distributed to negative x makes it a positive x. And the negative distributed to the positive 2 makes it a -2 or a -2. So we've got x minus 6 plus x minus 2 all over x minus 4. Continuing then, we've got like terms in the numerator that need to be combined. X plus x is 2x, and -6 and a -2 add up to a -8. And that's all over x minus 4. Okay. So we've combined like terms in the numerator. The very last thing to do when adding or subtracting fractions is to see if potentially you could factor the numerator and then maybe reduce by canceling a common factor. And looking at our numerator here, 2x minus 8, it does appear that we can factor it by factoring out a common factor of 2. So if we factor out the 2 from both terms on top, we'll have 2 times x minus 4 all over x minus 4. And lo and behold, we can cancel here the x minus 4 common factor and just arrive at the final result of 2.